So this is the B3C3P3 higher past paper 4 run through. Remember that you have this equations table in the front of your paper all the time. So in the physics section in particular, there's a lot of marks that can be gained just by making sure that you look up the correct equation. So first question is a biology section. So Amy and Sarah are identical twins. Their development began when an egg cell and sperm cell joined to form a zygote. The zygote developed into an embryo made of many cells. After about a week, the embryo split into two twin embryos. The two embryos grew to become Amy and Sarah. There it is. Put one tick in each row of the table to show which cells are haploid and which are diploid. So the egg cell and the sperm cell are haploid, and the zygote cells and embryo and cells in twin embryos are the diploid. If you got all correct, that's 2 marks. If you got at least 3 of them correct, so 3 or 4, then you only get 1 mark. What type of cell division happens to the zygote to form the embryo? That is mitosis. There we are. As an embryo grows into a fetus, a developing baby, one of the first organ systems that develops is the blood circulatory system. A human fetus is a double circulatory system. Describe one advantage of a double circulatory system compared to a single circulatory system. So that's just the idea that you can have a higher pressure or a greater rate of flow. That's for 1 mark. But you can also say that you can have different pressures in the lungs and the body. You could say there's a more efficient transport of oxygen, or you could say that the blood can be pumped around faster. Next question, the hemoglobin of a human fetus more readily combined with oxygen than the mother's hemoglobin combines with oxygen. Suggests why this is important. So there's 2 marks here. First one is for saying that the oxygen travels from the mother to the fetus, but the oxygen moved from the mother's hemoglobin to the fetus's hemoglobin. So it goes from the mother's hemoglobin to the fetus's. So first mark for saying the oxygen travels from the mother to the fetus. Second mark saying that the oxygen moves from the mother's hemoglobin to the fetus's hemoglobin. Next question, during growth the fetus uses oxygen to produce ATP. Why does the fetus need ATP? And that's for energy. The graphs on this page and the next page show height growth curves for girls and boys in the USA. The lines show percentiles. For example, the top line shows the 95th percentile. This means that 95% of girls or boys are at or below that height. At what age is there most variation in the heights of girls? So the greatest range is where you've got the biggest gap between the 5th percentile line and the 95th percentile line, which comes between 11 and 12. So the difference between there and there is the greatest. So you get a mark for saying any answer between 11 and 12. And then the second mark is saying that there's the biggest difference between the 95th percentile and 5th percentile. Then you've got another graph for boys. So Cash says that the graph shows that boys are taller than girls at age 20. Discuss whether or not he is correct. Use the graph to help you answer. So there are 2 marks here. You could say yes for 1 mark because the mean or median value for boys is greater than the average or mean value for girls, but no because some girls are taller than some boys. So there's 2 marks there, 1 for each side of the answer. The fact it says discuss means that you need to give both sides of the argument. So yes, because the mean for boys is greater than the mean for girls, but also no, because some girls are taller than some boys. During growth, different types of protein are made and used. Write about 2 types of protein that do different jobs and describe the job of each protein during growth. So there are 4 marks here. So you've got to give 2 proteins and then their jobs. So you get 1 mark for the protein, 1 mark for the job, 2 different proteins. So you could say structural proteins for a mark, to build new tissue. So that's that could be the first couplet. You could say that hormones for a mark control growth for your second mark. You could say carrier molecules for a mark, to transport materials for a mark. And you could say enzymes to control chemical reactions for 2 marks. So any 2 of those proteins with their explanation for 4 marks. Proteins are coded for by DNA. Describe how the DNA base sequence codes for protein for 2 marks. So the first mark was saying that it codes for the amino acid's order. So first mark, so it codes for amino acid order, or you could say amino acid sequence, and then the second mark is just saying that there's 3 bases for 1 amino acid. Or we could say 3 triplet codes for 1 amino acid. Sorry, 3 bases codes or 3 triplet codes for 1 amino acid. So this is a 6 mark question, so I'd like you to mark this yourself, please, using the mark scheme that you can find on the Google site that's written on your poster. If you're unsure whether you've marked it correctly, please see your teacher just for them to check it. Next question, if the selective breeding of bulldogs is not going to be banned, suggest how some of the health problems could be avoided in future generations. So 2 marks here. So you could say, for the first mark, you could say that don't selectively breed for large heads, flat faces or narrow hips. And you could say selective breeding for smaller heads, less flat faces, avoid breathing problems or wide hips. So the idea that you could selectively breed for a smaller head. And you could also say that for a second mark, better health care. Now on to the chemistry section. So carbon can exist in different solid forms. What is the name given to these 3 forms? So different forms of the same element are called allotropes. Next question. Look at the diagram. It shows the structure of a new solid form of carbon called graphene. Graphene contains 1 layer of carbon atoms. Graphene is made from graphite, and graphene is harder than graphite. Explain using ideas about structure and bonding why graphene is hard and graphite is slippery. So the reason why graphene is hard is because it has it only contains strong bonds, whereas graphite, which is different, is slippery because it has weak forces between the layers. And what I mean by layers is this here, the fact they're made of layers. Graphene is just 1 layer, whereas graphite has 2 layers, or more than that, are held together by weak forces, which means the layers can then slide over each other. But that will get you the both marks there, that point there, and that point there. Diamond and graphite have different properties and different uses. Look at the table, it shows some information about the properties of diamond and graphite. There they are. Diamond is used to make cutting tools. The picture shows a drill bit with diamonds on its end. This drill is used to cut through rock. Explain why diamond is used to make cutting tools. Use the table to help you. So there's 2 points. It's the fact that it's got a it's very hard. So it has just putting that diamond is very hard. You get the first mark. So putting that. And the second mark is saying the melting point's very high. None of the other points are relevant. So you've got to choose the 2 relevant points there to get those 2 marks. So the melting point's very high and the hardness is very hard. Next question. Hilary investigates the reaction between magnesium and hydrochloric acid. Magnesium chloride and hydrogen are made. Construct a balanced symbol equation. So I want everyone to be getting the first mark on these, which is simply by writing out the symbols. So these are reacting. So therefore those go on the left-hand side of the arrow. These are being made, so they go on the right-hand side of your arrow. So there are 2 marks for this. That tells you that there is a mark for writing that out. Let's get your first mark, and then you've got to balance it. So to balance this, you simply need 2 HCl, and that will balance it all out. and that's your second mark. You still get the first mark even if you balanced it incorrectly. Next question, look at the diagram, it shows the apparatus she uses. Hilary measures the total volume of gas in the syringe every 10 seconds. Look at the graph opposite, it shows her results. How long does it take for a reaction to stop? So you'll be able to see the graph if you've got this paper in front of you. So this is any answer between 47 and 51 will get you the mark there. So 47, 48, 49, 50 or 51 will get you the mark. Calculate the rate of the reaction during the first 10 seconds. So your answer there is 2 centimetres cubed per second. Because there were 20 centimetres cubed made in the first 10 seconds, you've got to divide that by the time taken. Hilary repeats the experiment. She uses the same mass of magnesium and the same volume and concentration of acid. This time she uses magnesium powder. On the grid, sketch the curve she gets. So magnesium powder will make the reaction go quicker. So on the graph, what you should have done is, there's 2 marks for this. One for making sure that the gradient is higher at the beginning, so starting off steeper and then levelling off at the same amount, because all you've changed is the form of the magnesium, not the amount you're using. So it'll go quicker, but you'll make the same amount of products. You've got to level off at the same point. 1 mark for the steeper, 1 mark for levelling off at the same point. Next question, magnesium sulfate and magnesium nitrate are both used as fertilisers. Magnesium sulfate can be made in industry by a continuous process. Explain why batch processes are used to make some pharmaceutical drugs, but continuous processes are used to make fertilisers. And there's 2 marks here. And this is really just the idea that of the difference between batch and continuous. So you can have the first mark for either of these, the idea that drugs are usually required in small quantities or small amounts, or that drugs are made as they are required, so that's your first mark. And the second mark is the idea that fertilisers are made in large amounts, or that fertilisers are made 24/7. So 1 mark talking about the batch process, the idea that drugs are made in small quantities, then 1 mark for talking about the continuous process, the idea that fertilisers are needed in large quantities. Next question is a 6-mark question, so I'd like you to look at the mark scheme and mark that yourself. Please ask your teacher if you're unsure whether you've marked that correctly. Next question. This question is about energy changes using chemical reactions. Cold packs are used to treat sports injuries. The cold pack reduces the temperature of the injured part of the body. An endothermic reaction happens when the chemicals in the cold pack react. Energy is absorbed when bonds break. Explain in terms of bonds between atoms why this reaction is endothermic. So this is the idea that you've got to talk about bond making and bond breaking. So it tells you that energy is absorbed when bonds break. So the first mark is saying that when bonds made, bond making gives out energy. And then for it to be endothermic, the amount of energy taken in has got to be more than the amount of energy given out. So more energy taken in than given out. That makes it endothermic overall. Amy and Luke investigate 4 liquid fuels. They burn an amount of each liquid fuel. Look at the diagram, it shows the apparatus they use. There it is. Calculate the energy transferred by ethanol. So, they give you the formula here, and all you've got to remember is that the mass is not the mass of the fuel burned. It is the mass of the water you are using. You have to remember that, otherwise you won't get the marks here. So it's 100 grams of water, so it's going to be 100 times the specific heat capacity, which is 4.2, times the temperature change, and that's ethanol, so that's 40 take away 20. You've got to work out that temperature change. So that's times 20, so that gives you 8,400. And then it says, Amy thinks paraffin gives out the most energy per gram. Use the results to show that she's correct. So you could calculate it for each one, but actually you've got the highest temperature change here, so that's 23 Celsius. It's the highest temperature change for the smallest amount burnt. So that's what your 2 marks are for. Just saying that the first mark is saying that the highest temperature change, second mark for saying that you've burnt the lowest amount. So the last section is a physics section. The first question in the physics section is a 6-mark question, which as for the chemistry and biology sections you're going to mark yourself using the mark scheme that can be found on the Google site. Hossein is a weightlifter. His best lift in training is a bar with a mass of 250 kilograms. He does 5,000 joules of work on the bar with a mass of 250 kilograms when he lifts it. The gravitational field strength on Earth is 10 newtons per kilogram. And the first question asks you to calculate the weight of this 250 kilogram mass and how high Hossein lifts the bar. So the weight is simply the mass times the gravitational field strength, which is 10 newtons per kilogram. So that's 2,500. Then you've got to use that to work out how high Hossein lifts the bar. Now, it tells you the work done on the bar, and you've worked out the force already. So work done, if you can look this up in the front of your paper, that's where it is. Work done equals the force times distance. So to work out the distance, you just need to divide the work done by the force. So this is going to be 5,000 divided by 2,500, which gives you 2 meters. Now, if you're unsure, then try and think about this logically. If you multiplied these two numbers together, then you would get a huge number for the number of meters, which obviously is going to be taller than Hossein. 2 meters is a sensible answer, because he could very well be lifting that 2 meters high. If you divide it the wrong way around, that will give you 0.5 meters, which would only be about this tall. So think about your answer and think about whether it's sensible before you carry on. Next question. Aditi looks at the table of stopping distances for a car. The thinking, braking, and stopping distances change with speed. The thinking time for the driver does not change with speed. Calculate the thinking time for the driver in seconds. So to work out the thinking time, you've got to do the distance divided by the speed. So there's going to be 6 divided by 9, and that will give you 0.66 or 0.67. Either of those two answers would be fine. Next question. Aditi says that 80 meters per second, the thinking distance is 9 meters. Is she correct? And explain your answer. So, no, she isn't correct, but that doesn't get you a mark. The mark is for saying that it's actually 12 meters, because that gets you 1 mark, and that's because doubling the speed doubles the thinking distance, or thinking distance is proportional to speed, or you can just do it from the calculation of 18 times 0.66, which equals 12. So 12 meters gets you a mark, and that calculation, just showing how you got there, gets you a mark. But if you didn't get there through the calculation and got there via the fact that doubling the speed doubles the thinking distance, you need to just explain that in words. Aditi says that 27 meters per second, the braking distance is 18 meters. Is she correct? So here it's worth 3 marks. So again, no, she isn't correct, but that isn't worth a mark. The marks are for first working out that it's 54 meters that the braking distance would be. And then you can say that for the other 2 marks, doubling the speed quadruples the braking distance for 1 mark, because kinetic energy is proportional, or braking distance is proportional to v squared, the velocity squared. Or you could say that kinetic energy is absorbed whilst braking. If you put that also gets you a mark. So 1 mark for 54 meters, 1 mark for saying doubling speed quadruples braking distance, and then 1 mark for saying that braking distance or kinetic energy is proportional to v squared. Next question says, complete the sentences for 3 marks. Stopping distances increase with speed and depend on thinking and braking. The thinking distance is the so that is the distance the car moves. While the driver is reacting. The thinking distance with increased speed but also increases the driver is, and there's a few things you could say: tired, you could say drunk, you could say distracted, you could say not concentrating, or you could say drugged for that mark. And then braking distance increases the speed but also increases the road, is, you could say, is icy, wet, muddy, slippy, or downhill, and or the tyres have little tread, grip or friction, or they're worn tyres or they're bald tyres. So you get 1 mark for saying that one, 1 mark for getting an answer for, so tired, drunk, distracted for here, and 1 mark for getting both of these. You have to have both of those for the third mark. So either wet or muddy or icy there, and saying that the tyres are bald there. Modern cars have many safety features. Some features protect people in a crash. Scientists use crash dummies inside real cars to determine their safety ratings. Look at the data from 2 crash tests at 15 meters per second. One is for a modern car, the other is for an old car. The forces on the crash dummies in the old car are much higher. Old cars do not have crumple zones. Use the information in the graphs to explain why crumple zones in modern cars reduce forces on crash dummies. So, there are 3 marks here. So you could say there's more collision time. That'll get you a mark. You could say that there's more collision distance. For a mark, you said there's less acceleration. That'll get you a mark. Or you could say that the same amount of energy is absorbed, or there's the same change in momentum for each car. Next question. More effort is now being made to keep pedestrians safer in car crashes. Scientists use dummies and cars in tests to improve pedestrian safety. Describe the steps that scientists take when carrying out these tests. So there's 2 marks here, so any 2 of these. So you use experiment with collisions on a dummy. You could say that you collect the data or the measurements or results from the collision, then draw conclusions from this data for a mark, and then change or recommend changing in design or the experiment. So, for example, you could try dummies of different heights, try crashes at different speeds, make the bumpers lower, so change the design or experiment to see whether the collision would result in a better result. So any 2 from those things. So first mark could be for the experiment with a collision on a dummy. Second mark could be for just saying that you collect the data or the measurements. Third mark, you could get a mark for saying that you draw conclusions from the data. And then the 4th mark you could get for saying that you change or recommend changes in the design or the experiment. And the last question, these scientists will publish their results. Why is it important to publish the results? So any one of these, you could say that it's important so that other scientists can develop more or improve the tests or research. You could say that they could look at their conclusions or findings, or you could say check accuracy. You could say to see if their research agrees. You could say that to add more data. You could say to inform the future design, or to inform customer choice, or you could put so that people can choose the safest car from the data. So add up your marks, write it on your poster, and then try the next paper and see if you can get more.